Our last two transformations that we're going to talk about for our mini unit are translations and dilations. So keep in mind, translations, that's a very specific term. When you translate something, that basically means you're shifting this in like one or more directions. This is different from a transformation, whereas transformation means any type of change to your figure. So that could encompass our reflections that we talked about, our rotations that we talked about, our translations, or our dilations that we're doing today. So be careful that you remember the difference. Transformation is any change of a figure. Translation is just a shift. And so specifically, we're going to look at a couple examples of translations. Our first one is we are going to translate a triangle up 4 units. So if we think about our X and Y coordinates, which ones are the ones that actually control where we're going up or down? Well, those are our Y coordinates. So when we translate up 4, that really means all we have to do is change our Y coordinates. Specifically, we're going to add 4 to all Y coordinates. So again, if we use kind of our formal way of writing out these rules, that means changing any points x, y to x, y plus 4. So let's look at the 3 points that we have in our diagram. Again, we don't have them written out, so let's go ahead and jot these down. So we have point A, B, and C. Our A is at -3, -1. Our B is at 1, -1, and our C is at -2, -4. So if our rule is that we're going to try to shift everything up 4 units, again, we could just count this on the graph. But again, we want to practice doing this just in case we have larger coordinates that we can't easily see on a graph. Maybe we don't have big enough graph paper for it. So all we have to do is add 4 to all our Y coordinates. So that would make our new A prime, -3, +3, because -1 plus 4 gives you the +3. Our B prime will be 1, +3 again, because they have the same Y coordinate. And then our C prime is going to be -2, 0, because -4 plus 4 is 0. So graphing this out, again, A prime is at -3, +3. So again, on the graph, notice it looks like I just moved that point up 4 units. That's exactly what we're trying to do. Our B is at 1, 3, again, just shifted up 4 units. And our C is at -2, 0, C prime. And when we draw in our triangle, that makes it even easier to see that all we did was move all 3 points up 4 units. That being said, when we look at translations, it's not just moving up or moving right. Usually it's a combination where we're going to slide it like diagonally up to the right, down to the right, up to the left, down to the left, whatever we need to for that scenario. So let's look at one where we're doing 2 transformations. So this one is translate right 3 and then up 5. So right, that means which coordinate are we changing? We're going to add 3 to our x's. And if we're moving up 5, same thing as before, we're going to add 5 to y. And if we write this out formally, our rule is going to look like x plus 3, y plus 5. So same figure, so we're starting with the same points. I'm not going to worry about writing them again, but you might want to. We just need to worry about, well, where do our new points end up? So original A point, if our x was at -3 and we add 3, that means our new x coordinate 0. If we add 5 to the y, that means we're going to be at 4. B prime and C prime, same thing. And actually what I like to do, if I'm working on a shape, I tend to do one of my computations right around or right in a row. So let's do the rest of our x's, which we know we have to add 3 to. So B was at 1, 1 plus 3 is 4. C was at -2, -2 plus 4 is 2. Excuse me, 3 is what I'm adding. So that is a +1. So then we need to do the same thing with our y's. So add 5 to all of our original y coordinates. B had a -1. -1 plus 5 is 4. C was a -4. -4 plus 5 is 1. So let's plot it and see if this worked. So A prime at 0, 4. B prime at 4, 4. And C prime at 1, 1. So again, it looks like I just shifted it up and over, which was the whole point. Do remember too, it's very important that every time I'm drawing these new shapes, and you saw this in the last video as well, I'm putting these markers prime, a little apostrophe on my letter. That just makes it that much easier for me to figure out where was my original point. And so if I need to figure out, how did I change it to make my new shape? So let's look at a couple more examples. So our next one, we are looking at performing a translation, and our rule is x plus 3, y plus 1. And we're going to do that on the quadrilateral RSQU. So again, let's start out by figuring out first what all our coordinates are. So our R coordinate is sitting at -1, -1. S is at 0, 2. Q is at 3, 1. And U is at 2, -2. Alrighty, I like these rules the best because if they're using this to describe translations, which is most often the way they describe it, then all we have to do is add or subtract to our X and Y coordinates, and we're good to go. We know exactly where to plot it. So new coordinates, again, let's just go down the row and do one of the coordinates at a time. So for R prime, S prime, Q prime, and U prime, first thing is let's do our X's. So all of our X's, we have to add 3. Okay, so -1 plus 3 gives me 2. 0 plus 3 gives me 3. 3 plus 3 gives me 6. And 2 plus 3 gives me 5. Alrighty, then Y coordinates, we just have to add 1. So on our R prime, that gives us a 2. See, S, 2 plus 1 is 3. Q, 1 plus 2, 1 plus 1 is 2. And then U, -2 plus 1, -1. So let's plot our new shape. So R prime is at 2, 2. That doesn't seem right. Ooh, there's my error. Can you see where it is? Ah, we started with a -1 plus 1. What should we have? Yeah, we should have a 0 on that one, shouldn't we? This is why it's important, write things out, perform your rule, then graph your picture. You can check your errors a lot easier when you're writing things out. So let's put our R in the correct spot. So 2, 0. There's our R prime. Again, it looks like it's in the middle of the shape, but let's see what happens. We'll see if we have to fix anything else. S is at 3, 3. So S prime. Q prime is at 6, 2. 1, 2, 3, 4, 5, 6, 2. And count carefully. U prime is at 5, 1. 5, -1, excuse me. And when I connect my dots, it absolutely looks like I just took my square and shifted him up to the right. All right, let's try one more, but this one's asking the question a little differently. So for this one, you actually have both of your figures. We have a triangle, ABC, and it got translated. And so our job is to write the rule that describes that translation. Okay, so pick a point, and we just need to figure out how it moved. So I'm going to start at the beginning of the alphabet. Let's look at the A. So from A, it moved to A prime. So what happened? How far does it have to go to get there? Well, in my X direction, it has to go over 3. In my Y direction, it has to go down 4. So how would we describe that if we changed our XY coordinate and we just said that it had to go to the right 3? What do we do to the X? Add a 3. If it had to go down 4 in the Y, subtract a 4. So let's see if that works. Let's check our other two coordinates just to see if that rule applies. So our original B was at -2, 4. If we apply that rule, -2 plus 3 gives us 1. 4 minus 4 gives us 0 is our new B prime at the point 1, 0. That works. Let's check C just to make sure. Original C was at 0, 2. If we apply our rule, okay, 0 plus 3 is 3. 2 minus 4, negative 2. And that is exactly where C prime is. Awesome, our work checked out. Alrighty, so last kind of transformation we're looking at is a dilation. Now be careful. So just in terms of the wording, and again, this is not English class, so we're not as worried about spelling. You'll still be able to recognize what it is, but a lot of people pronounce this as dilation. And really, when we're talking about geometry, we don't have that extra A in there. It's just dilation. So keep that in mind when you're speaking about things. I know you might have, gone to the eye doctor and they gave you these drops and it dilates your eyes. Again, you're changing what? What's happening to your eyes when you get those drops? It's relaxing your iris muscle. So your eye, I'm not remembering the word off the top of my head, but so more light is let into your eye and your eye doctor can see, hey, are your eyes healthy? Exactly the same thing is happening with geometry when you're performing dilations. We are changing the size of our figures. So first one, we're going to dilate by a factor of 1/2. And all we need to do, if we're going to change the size of something, is, for example, if I knew a length of a segment and I wanted to make it half as big, I would just multiply it by 1/2 or divide by 2. So that's what we're going to do. We're going to multiply by 1/2. That's it. So our formal rule to write it out would look like xy would turn into 1/2 times x and 1/2 times y. So again, let's write down our points since we weren't given those. So we don't even have names on these, do we? So we should label those. So let's label as A, B, C. So our point A is at 2, 4. Our point B is at, let's see, 1, 2, 3, 4, 5, 6, 4. And our point C is at 6, 2. And so to perform this dilation, A prime, multiply everything by 1/2. Okay, so 2 times 1/2 is 1. 1/2 of 4 is 2. So B prime would become 3, 2. C prime would become 3, 1. Again, I'm just dividing each number in half, or technically multiplying it by a 1/2 or divide by 2. So our new points, 1, 2 for A prime, 3, 2 for a B prime, and 3, 1 for a C prime. Connect the dots. What does it look like happened to our triangle? Yeah, we shrink it. So all of our sides are half as long as our original image or our pre-image. In fact, too, you'll notice it actually shrank in towards the origin, which is what we're going to be looking at with most of our transformations. When we ask you to do dilation, it's always going to be around the origin, although you still want to recognize, hey, a dilation by a factor of 1/2 would make something smaller. So let's do dilate by a factor of -2. So there's actually 2 things going on with this one. We're going to do this the same way. So all we're going to do is multiply everything by -2. And so again, formal rules, pretty easy to write out, 2x, 2y. Again, we need our points. So let's go A, B, C, and D. So A, B, C, and D. A is at 1, 2. B is at 3, 2. C is at 3, 1. D is at 1, 1. So again, nice small rectangle. So now if we apply our rule, multiply by -2. Oops, what did I forget to write in my rule? I forgot my negatives. So make sure you have those written in. So multiply every single coordinate by -2, and let's see what happens. So our A prime would become -2, -4. B prime would be -6, -4. C prime would be -6, -2. and D prime would be -2, -2. Wait a second. What's happening here? Where are all of our points going to be if everything's negative? Well, everything's going to be in that bottom left quadrant. Let's see what else happens to it. Let's graph and see what it looks like. So A prime at -2, -4. Okay, so there's A prime. B prime at -6. So 2, 3, 4, 5, 6. -4, there's B prime. C prime at -6, -2. And D prime at -2, -2. So what does it look like happened on this one? So actually two things happened. This looks like a much bigger triangle. Actually, all the sides are twice as big, but also everything got flipped around. So the D is still the closest to the origin. The B prime is still the furthest away. And think about what happened when we were doing our reflections and our rotations last lesson. When we moved things to another quadrant, we had to adjust those negative signs as well to make sure that we were in the right placement in our quadrants. Anytime you're dilating by a negative number, it's actually going to do the same thing as when we were reflecting in the origin, where everything gets flipped across to the other side of the graph. So let's see this. Let's actually apply several transformations to the same shape. And again, we'll see if our predictions can come true. Okay, here we go. So we are given a triangle, JKP. And again, we don't have the coordinates written down, even though they're labeled really nicely. So I'm going to go ahead and write those down. So our coordinates for J are 2, 4. Coordinates for P are 4, 2. And our coordinates for K, I'm going to count it out, 1, 2, 3, 4, 5, 6, 4. So with each of our dilations, all we're doing is multiplying by that dilation factor. That's it. Okay, so let's mark this guy. This is our pre-image, so I'm going to call it pre. And now let's go ahead and make our first one. I'm going to change to purple. So let's write our coordinates over in our margin. We're going to need J prime, K prime, and P prime. Oops, sorry, my brain is already jumping ahead to the first step. This first one, we want to dilate by a factor of 2. So multiply all your coordinates by 2. So that means J will become 4, 8. K will become 8, 4. And P will become, oops, I flipped these around. Let's go in the same order as I had them listed before. P prime and K prime. And that way I won't have to worry about my coordinates getting goofed up. So we'll have 8, 4 for our P prime, and K prime will be 12, 8. This is why we have the bigger graph to make sure it works. Okay, so 4, 8, 4, 2, 4, 6, 8. There's our J prime. K prime, or excuse me, P prime is at 8, 4. So 4, 4, and 8. There's P prime. And then K is at 12. Wait, 8, 9, 10, 11, 12, and 8. 1, 2, 3, 4, 5, 6, 7, 8. There's K prime. Hey, multiplying by 2 again did 2 things. So dilation factor of that one was 2, twice as big, and stretched out further away from the origin. Awesome. Let's try out the next one. I'm going to change my color to green for this one. So let's do B. I'm going to put them on this other side because that's where our information is listed. Okay, so same thing. We have a second apostrophe. So J double prime is how we would say it. K, P double prime. Okay, I see why my brain is flipping those around, is because it was named as triangle JKP, but I wrote the points in the other order. It really doesn't matter. It's all making sure you can keep track of which coordinates are which. Okay, so this one we're multiplying everything by 1/2. So just divide every number by 2. So our new J would be 1, 2. New P would be 2, 1. New K would be 3, 2. Okay, so 1, 2 is our J double prime. 2, 1 is our P double prime, and 3, 2 is our K double prime. And that's our 1/2 dilation factor. All right, it might be a good idea, try pausing the video and trying out the next two. Again, both of these are negative. So think about what that would mean with where they'll end up on the graph and which one has a change of size. So let's see how we agree on our work. Let's go back to red. So let's do transformation C. We're dilating by a factor of -1. So in other words, if we multiply by a -1, what's the only thing that happens to our values? Yep, they just change signs. So J triple prime, it's going to be -2, -4. P triple prime is -4, -2. And K triple prime is -6, -4. Okay, plot them out. -2, -4, J triple prime. Okay, -4, -2. There's our P triple prime. K is at -6, -4. K triple prime. There we go. Completely flipped around directly across the origin. So that's our -1 factor. Okay, and last one to do, let's go over on the right-hand side again. So I'm going to change back to regular old black ink, and let's see what happens. So again, I'm going to write these over here because I'm running out of room. No, I can get them down at the bottom. Okay, and you'll see why I'm writing it down here this time. Okay, fourth one, so quadruple prime, 1, 2, 3, 4, and P and K. So I actually have to shrink this down so we can see our coordinates. So again, multiplying by a factor of -2, so just multiply through by a -2. All righty, so -4, -8, -8, -4, and -12, -8. So let's see what this looks like. So -4, -1, 2, 3, 4, 5, 6, 7, 8. There's our J quadruple prime. P quadruple prime is at -8, -4. P quadruple prime. And then K prime, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then down 1, 2, 3, 4, 5, 6, 7, 8. K quadruple prime. And there is our triangle that is twice as big and flipped around. So that's a -2 dilation factor. Alrighty, so your practice today will encompass all of your transformation practices to help you prep for your activity tomorrow, which will be where you show what you've learned. Let us know if you have any questions.